If you're a programmer, you love to take a look at programming languages. And one of the most popular ones that's coming up these days is Rust. Using Rust has been all over the place, from the internet to embedded systems. And it's especially good for safety critical systems. So Florian, could you tell us why Rust is going to be probably the preferred way of developing embedded systems?
Okay, there's two parts here, the safety and the embedded systems. I'll start with embedded systems. Rust is really interesting for embedded systems because it is by design a language that scales up from the microcontroller to the cloud. That has been quite a bit of work, but it's actually one of the few languages that is memory safe, but can be used on any kind of device. Practical comparison here, for example, Swift also has grown similar capabilities recently, but it uses a different language profile. While Rust on the microcontroller is, on the language side, like Rust on the server. And that's, from the design, a very, very useful thing to have, because that means you can actually share code between microcontrollers and servers, and there's quite a lot of practice where people are actually doing that. And I think it's a little bit less of, like, the language is really good, but also the ecosystem around it really has that in mind. And I think this is we often talk about languages like they are these isolated things, or they're actually growing these huge ecosystems. And coming into safety, I think that is also something that we're currently seeing, is like there's a desire in safety to connect to popular ecosystems and use practice and ideas from there. And for them, it is really good that Rust represents values that safety critical systems have been representing for 20, 30 years, like resilience, correctness. If you think about Facebook in 2013, they've been like, move fast and break things. This is incompatible with safety critical. But nowadays, the engineering, even at the big cloud vendors, is working very differently. There's a lot of intersection nowadays where, well, as I said, correctness and resilience are getting very, very important, and Rust owns that as a value set.
Now, one of the reasons that this is the case is because effectively the programmer has put a lot of responsibility into the compiler, and that gives a level of consistency. Could you talk a little bit about some of the areas where Rust excels in this area?
Well, the compiler in Rust is essentially a little bit of, if we move the compiler a bit into formal verification, we can help the programmer more. It's like formal verification without actually feeling it. That also means that the compiler plays a very significant role in the interplay during day-to-day coding. That means two things. First of all, from the compiler side, that means there's a lot more interaction. You can see that from the get-go, where Rust put a huge emphasis on good error messages. Like, these may be logically hard to track bugs, but the compiler can help you by actually having multiple people on the team working consistently on better communication to the programmer. The other part of that, though, is that there's a high level of quality assurance needed on all levels to actually make sure that the tool is reliable. So making sure that it doesn't, well, reporting errors where there is none is a little bit less of a problem, but actually compiling wrong code where you're actually trusting your compiler to a much higher degree than you would do at other points is a problem.
Well, one of the aspects of safety critical applications is typically they need to be supported and certified. And Rust, being an open source project to start with, needs to be addressing that in a couple of ways. That's one of the things that Ferrous Systems does.
Yeah, so we have a project called Ferrocene, which is, in open source terms, a downstream. So we are taking the Rust compiler and additionally running additional validation. Usually, as a bit of a punchy mode of saying that, I usually say we're taking the gut feeling that the Rust compiler is high quality to an actual argument on why it is high quality and at which places it is high quality and which places it's not. Because the Rust compiler has experimental areas, and people who have been, like us, been involved in the Rust project for years are like, yeah, we know that this thing is a little bit unstable, or this sometimes, like, don't use that in your last production build. The problem, and this is a challenge that Rust currently has, is, and I've been part of the Rust project since it was like a couple of 10 people, there's a certain scale or where you need to start writing these things down. And to take that a little bit beyond, the strength of safety critical is that it has methods like qualification, safety manuals. It has a language around this. What do you do? How do you argue? How do you take this gut feeling of this thing is high quality to actual tangible evidence that it is high quality? Which I think it also helped the Rust project knowing, okay, these are areas where we're good and these are areas where we're bad. So these are the things that we're doing in Ferrocene. From the perspective of someone who just wants to use Rust, we're a Rust compiler vendor that provides safety qualified Rust compilers, and additional support for whatever they want, which open source projects usually don't do and structurally can't do.
Well, let's talk about the latest qualification that Ferrocene has. What is it and why is that important?
So we've now qualified also for medical devices. We used to do industrial and automotive before. And that's actually because there's a lot of requests coming out of that area, particularly because cybersecurity demands on medical devices, particularly in the US, have been raised in the last couple of years. So the Federal Drug Administration is now actually looking at cybersecurity as part of the certification process. Previously, that was something they could give you a yellow flag for, but you could pass. Nowadays, you could actually be denied certification for that. So using a language that already cares a lot about cybersecurity and correctness and stability boosts your development process. And getting a qualification makes it easier in your project to just be assured that that tool is something that will be accepted.
Well, very good. Well, thanks for filling us in on Ferrocene and Ferrous Systems and how Rust can be used in safety critical applications.
Thank you very much. Thanks for having me.